Welcome to everyone. Today I am going to discuss about understanding embedded systems. An embedded system is a specialized computing system that is designed to perform dedicated functions or tasks within a larger system or product. It is typically built around a microcontroller or microprocessor and is responsible for controlling specific hardware and software functions. Embedded systems are everywhere around us. For example, in a modern car, there are embedded systems controlling the engine, navigation, infotainment, and safety features. In smartphones, embedded systems manage communication, touch screens, and sensors. Even household appliances like washing machines and microwave ovens rely on embedded systems for control and automation.
Chapter 1: Basics of Embedded Systems. Overview of Embedded Systems.
An embedded system is a combination of hardware and software designed for a specific purpose. It's embedded within a larger system, ensuring seamless operation of that system.
Differentiate between general-purpose computers and embedded systems.
General-purpose computers, like desktop PCs, are versatile and can run a wide range of applications. Embedded systems, on the other hand, are dedicated to performing specific tasks and are often resource-constrained. Key characteristics of embedded systems.
Real-time operation.
Embedded systems must respond to inputs and produce outputs within defined time constraints.
Dedicated functionality.
They are designed for specific tasks and do not have a general-purpose nature.
Resource constraints.
Embedded systems often have limited processing power, memory, and storage.
Chapter 2: Hardware Components of Embedded Systems.
Microcontrollers and microprocessors. These are the processing units of embedded systems. Memory, ROM and RAM. ROM stores the firmware, while RAM is used for data and program execution. Input and output, input-output, interfaces. These enable interaction with the external world. Sensors and actuators. Sensors collect data, while actuators perform actions based on that data.
Chapter 3: Software in Embedded Systems.
Firmware. It's the software permanently stored in ROM and contains the instructions for the embedded system's operation. Operating systems, RTOS and bare metal. Some embedded systems use real-time operating systems, RTOS, for task scheduling and resource management, while others operate without an OS, bare metal. Application software. This is specific to the embedded system's function.
Chapter 4: Programming Embedded Systems.
C/C++. These languages are widely used due to their efficiency and portability. Assembly. In some cases, low-level assembly language is used for precise control. Embedded systems are typically programmed using integrated development environments, IDEs, that provide compilers, debuggers, and simulators.
Chapter 5: Real-time operating systems, RTOS.
RTOS ensures that critical tasks are executed on time, making it essential for applications with strict timing requirements. RTOS manages task priorities and schedules them accordingly. It allocates and manages system resources efficiently. Power consumption optimization. In battery-powered devices, minimizing power consumption is critical. Memory management. Efficient use of memory resources is essential. Reliability and fault tolerance. Embedded systems must operate reliably, and fault tolerance mechanisms should be in place.
Various applications of embedded systems across industries.
Automotive. Embedded systems control engines, airbags, infotainment, and more. Consumer electronics. Smartphones, IoT devices, and home automation systems heavily rely on embedded systems. Medical devices, pacemakers, insulin pumps, and diagnostic equipment use embedded systems. Industrial automation, PLCs, robotics, and control systems are integral parts of manufacturing. Provide examples of specific products or projects where embedded systems played a crucial role in achieving success. For instance, the use of embedded systems in Tesla's self-driving cars or in smart thermostats like Nest. Thank you for joining us today on this journey into the world of embedded systems. We've explored the fundamentals, hardware, software, and real-world applications of these incredible technologies. Embedded systems are the unsung heroes behind the devices and systems we rely on daily, from our smartphones and cars to medical equipment and industrial machinery. Understanding how they work opens doors to endless possibilities in the world of technology. Remember, the world of embedded systems is vast and ever-evolving. Keep exploring, keep learning, and keep innovating. Your curiosity and knowledge could be the driving force behind the next groundbreaking embedded system. Stay tuned for more exciting topics and lectures here on my channel. Until next time, keep coding, keep creating, and keep pushing the boundaries of what's possible with embedded systems. Thank you for being part of our community, and we'll see you in the next video.